Hello, class. My name is Professor Sharon Chandley, and I received my bachelor's degree from Boston University in psychology and women's studies, and my PhD in experimental psychopathology from Tufts University. And we are here today to talk about the brain, and specifically the lobes of the brain, because if you didn't know it, your brain has 4 distinct lobes. So the learning objectives for this lesson are first to be able to locate the lobes of the brain, to be able to identify one function for each, and to understand one result of brain injury or illness in depth. And believe it or not, we're going to do this all in 5 minutes. So let's start at the back of the brain. At the back of the brain are the occipital lobes, and this might seem kind of startling because your eyes are here, and that information about vision travels all the way back to the back of the brain, but that's how it happens. And so in this part of the brain is your primary visual cortex, responsible for most of conscious aspects of sight. And if you damage this region of the brain through injury, you will be functionally blind, even though your eyes are working perfectly just fine and doing everything they should be doing. If this part of the brain is damaged, you won't be able to consciously see. But one interesting exception to that being true is this phenomenon called blind sight. And what it means is that there are other regions of the brain in other lobes that are responsible for aspects of vision such as motion and direction. So not seeing in the conscious way that we think about it, but for detecting motion and direction. And so you may have seen clips on movies or on YouTube where people who are functionally blind because of damage to the occipital lobes can still catch a ball that you throw at them, for instance. They have no conscious perception of seeing the ball, but yet they can catch it. Remarkable. Coming down underneath the brain are the temporal lobes. We have one on each side. A lot of auditory information is processed here in the temporal lobes, which kind of makes sense because it's near the ear. Also, many regions involve understanding and producing spoken language, and some emotional and motivational behaviors live here. One interesting structure embedded in the temporal lobes is called the fusiform gyrus, and you can see it here in blue. The fusiform gyrus is a temporal lobe structure involved in facial recognition, detecting people's faces and being able to tell, you're my sister, you're my teacher, and you're my friend, just by looking at somebody's face. In fact, if you damage this region of the brain, if you damage the fusiform gyrus, you might experience something called prosopagnosia, which is a disability where you cannot recognize people's faces. You can often figure out who they are by context clues. If the person standing in front of the class with a chalk eraser is probably your teacher, for instance, but you have trouble actually distinguishing people just using their faces alone. And I didn't know this until recently, but apparently Brad Pitt has prosopagnosia. All right, above the temporal lobes, but behind the front, we have the parietal lobes. And these are the regions of the brain involved in attention and spatial location. So figuring out where things are in space and pointing your attention to them. An interesting phenomenon can happen if you have damage to the parietal lobes, often through stroke, which is something called spatial neglect. And this happens especially if you have damage to the right parietal lobe. You may stop attending to the left side of space. And it's not that you don't see the left side of space. If I draw your attention with my finger and point to it, you can see it. If you move your head, you can see it, but you don't pay attention to it. And so folks with spatial neglect, for instance, if you gave them these models of the clock and the house and the flower here on the left, they would draw what you see on the right. They would just neglect the left side of these images. Finally, the frontal lobes at the front, very descriptive, are involved in motor control, especially fine motor control, so moving your body voluntarily, and also what we call executive functions. And executive functions are all those kind of intellectual planning, delay of gratification functions that we think separate us from a lot of the rest of the animal kingdom. So things like planning and selection, persistence in ignoring distracting stimuli, memory for things you've already done, memory search, and responding to context. And there is unfortunately a terrible form of dementia called frontotemporal dementia, or FTP, that attacks the frontal lobes, and there is a deterioration of them. And people with this disease rapidly lose a lot of cognitive function and their personalities are forever changed. So there we have it, frontal, parietal, temporal, occipital. Hopefully you learned a little bit about their function and one form of injury or illness in depth. Thank you.